not sure how to start it.
Do you know how to find the distance between 2 points?
D equals square root of x2 minus x1.
Yep.
Plus y2 minus x1. But those are squared, I think.
Yep. Basically, it's Pythagoras. And so this one is 3D Pythagoras. It's much simpler than it sounds. So it will be the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared.
So what is the z coming from?
The third coordinate. Third digit, I suppose. So you have 6, 3 minus 3, so that's 3D now.
And the whole of that is equal to a to b to 5 root 5.
Yeah. So it's just Pythagoras.
So minus 4, 5 root 5 is equal to minus 4 minus 6 squared plus k minus 3 squared plus 0 plus 3 squared.
Sounds good to me. And then how do you go about finding out what k is?
So 5 root 5 is equal to minus 10 squared plus k minus 3 squared plus 3 squared. So 5 root 5 is equal to 100 plus k minus 3 squared plus 9. So would you square each side to get rid of the root symbol?
Yeah, you could.
So So 5 root 5 squared equals 125. And then 109 plus k minus 3 squared. So 125 minus 109 equals 16. So 16 is equal to k minus 3 squared. So 4 equals k minus 3. So k equals 7.
Let's take a look. Shift solve. So I just put it into my calculator. 5 root 5 is equal to the square root of minus 4 minus x squared all of that. I put in x instead of k, because that's all I can do. I'll get 3. Oh, it's telling me x is -1. Shift solve. Let's try lucky number 7. Oh, this time it's giving me 7. Does that mean... Oh, there are 2 possible values, are there? Values of k. Yes, that is because when we square both sides... yes, there's 2 possibilities. And so 5... So I think it was plus or minus 125. No, hang on, sorry. Yeah, so it would be 125. Yeah, so basically it's plus or minus. This one was minus 100. It was 100, was it? Yeah. Then the
109.
9. And then that's equal to the k minus 3 squared. And so that's 25. That was 16, was it? Yes. And so when you square root both sides, it's at this point, it's plus or minus 4 is equal to k minus 3.
Yeah, okay.
And so you did k is 7.
Yeah.
And so what would be the other possibility?
-1.
Yes. Yeah. Or k is equal to -4 plus 3 minus 1. Great. Any questions there?
No.
Okay. And I prefer my way because I didn't have to do it. But maybe I would have lost one of those because I would have been happy with just one answer. Although to be fair, I'm never happy with that one answer. Okay, how do we do this thing?
Could you move it down a little bit, please?
Yeah, you cheat on Monday. Where is it?
Why is there k?
So it's a tricky question. It's a separate question though. Oops.
Do you want to find the magnitude of each vector?
Yes.
So would it be the square root of 5 squared plus 2 squared minus 1 squared?
Okay.
Which equals 2 root 7.
Okay.
And B to C would be the square root of minus 7 squared minus 10 squared plus 4 squared. It says math error.
I think it's because If we were to sketch this triangle, so let's say A and that's B. And so then we have B to C minus 10, so something like there. And so I just called, so A to B is this one, B to C is this one, and then we need the angle BAC, so we wanted this angle. I believe to find that angle, we would need to have AC.
So.
Oh, so I think you were using the cos rule. Is that what you were thinking of?
No, I just thought that we were gonna use find the magnitudes of each side.
Yeah. And then I think you would use the cosine rule to find the angle. Basically, you'd have to use trig to find the angle. Vectors, if you work it out, you get this simplified thing. Cos theta is equal to A dot B over the magnitude of A times the magnitude of B. But that is for B to A to C.
What does the dot B mean?
A dot B, so that is x1 times x2 plus y1 times y2 plus z1 times z2. So that's x1, x2 plus y1, y2 plus z1, z2. And that's all over the magnitude, which is the Pythagoras. And so, what would it be for this one?
How do you type it in on your calculator?
So, you would accept that of this k. So let's see, x1 times x2. So that's just going to be 5 times minus 7.
Mm-hmm.
Then plus 2 times minus 10. And then plus minus k. Hang on, j, is that ijk? Oh, sorry, that's just minus 1. Your magnitude thing should have worked. Yeah, plus minus 1 times 4. And that's all over the magnitudes multiplied by each other.
For the magnitude of A to B, I got 2 root 7.
And you said you didn't get it for the second one?
No.
B to C. Why not?
I don't know.
It should be just the square root of minus 7 squared. Did you put it in a bracket?
Yeah.
Plus minus 10 squared. It'll definitely work because it's when you square it becomes positive.
Yeah.
So root 165. And so what do you do next?
degrees, does theta equal cos to the minus 1 of all of that?
Well done. Arc cos of all of that. And that is the angle. And so we got to do it.
I got 112.5.
112.5 degrees. And I'm in radians. I'll keep mine in radians just in case that's what they want. 112.5 degrees. 127.1. Angle unit press 2 degrees. I'm getting 150.2. Okay, is it just like a minus sign or something? Who knows? I could check something. The magnitude of the first one. Square root 5 squared plus 2 squared plus 1 squared is root 30.
I thought that we had to minus 1 squared.
What is minus 1 squared?
1.
Yep. Which is the same as plus 1 squared. So it'll be plus 1. The negatives are in a bracket. So I think that's why you couldn't. So you see, for the second one, each of my three are in a bracket, and so that's what you have to do. Is you can get away with it for positives, but for negatives, the squared is in a bracket because it's minus 7 squared. It's not minus the square of 7.
Yeah. Okay.
Yeah. Otherwise, you get a negative number, and you can't square root a negative. So we said it was root 30, and so I'll change the 2 root 7 into root 30. And I get 150, and they get 127. Why? Was there some other sin that I committed? 7, 10, 4. 7, 10, 4. And inverse cos. I'm pretty sure it's cos. A dot B 5 times minus 7 plus 2 times minus 10 plus minus 1 times 4. Oh, I don't know. My thing is slightly off. Did we use a rounded answer? I don't think so. We want the angle between. Let me go to Bookie. So vectors 12.1. 3D. Find a distance. Possible values. Vector. Angles. So they start with an easy one. Find the angle. Let me just see. 2 points. This and this. Find AB. That's A to B. No. They're snaking me. Yeah. Coordinates. Oh, Bucky doesn't like me. Bucky doesn't like me at all. Let's see. I know this is correct. So let's say angle between two things. Let me just find angle. Why did I have to get it wrong? Oh, it's gonna go all the way now. Okay. I just want to find one that's exactly it, because there's one up there that's kind of similar. Given that the angle is that. Bookie. So there's no similar question. Mixed exercises. Why would they throw this in? Angle. We want angle. Find the angle ABC. Okay, this one is exactly the same. Question 7. Of mixed exercises for vectors. Come on, Bucky. Okay, vectors. This is mixed, and it's question 7. 7 is there. Okay, so let's see how they went about this. So 7, A to B is that, B to C is that. So I'm thinking it's going to be -1 times 1 plus 1 times -3. It is not. Is it just plus on the top? 2 plus 11 minus 5. Oh, I'd have to... 2 plus 11 minus 5. Oh, why? I have to go to my old one, my good one. Core 4 vectors. Vectors might be in here. Position, equation. Why would they not just give me the formula? We want dot, yes. Okay, that's the formula. Cos theta, A1, B1, A2, B2, A3, B3. 2 times 1 plus 6 times minus 1. 2 times 1 plus 6 times minus 3. Minus 3, yes. Plus minus 1 times 3. Plus minus 1 times 3. And then that's over the two magnitudes multiplied by each other. And so this is, find the angle between this vector and this vector. Okay. We go back to this question 7. AB is that. BC is that. Find A, B, C. A to B. Are they doing some silly thing where, because it's B to C, so you have to do it backwards? So let me think about this. So A to B, that's minus 1i. That's plus 1i, but in the other direction it'd be minus 1i. So would that be 1? That's not it at all. Let me look at their example thing. It's not exactly the same. The angle makes with the positive coordinate axis. So they do the magnitude of A. Then they do cos of the angle is equal to 2 over that. So where does this 2 come from? That's the important bit. With each of the positive coordinate axes. So this is with the, oh, that's just the x-axis? X over the magnitude of A. So that's 2 times, I don't know. There's one little thing that I'm missing. So usually you'd find the angle between two vectors, whereas here I think it's backwards. Okay, let's see. So A to B is one vector. So this is the vector A to B. Then B to C is this other vector. Yes, I think that's because that's going in the other direction. So I think we have to do C to B. And so I think we need to change the signs for all of these. So I think this has to be plus 7, plus 10, and minus 4. What would that change? That would not change the magnitude, but it would change the number on top. And so that would be minus 4. That would be plus 10, and that would be plus 7. Let's try it. So that's minus 4, plus 10, plus 7. 29.77.
I think on the bottom it's meant to be root 30 instead of 2 root 7.
I thought I fixed that. Ah, I didn't.
Yeah, but you typed in again.
No, I've been putting in the wrong one. There's the root 31. Okay. So that's 146. Let me see. Okay. Minus. Plus. Plus. 33. This is cosine. 360 minus won't work. 180 minus. Alright, I'm going to have to look at this some other time. No, I'll have to look at that some other time.
Okay.
Angle between two. That's going to bother me. Okay, how about this one? That's a particle.
How do we find the acceleration?
Do you know any equation that involves force and mass and acceleration?
Force equals mass times acceleration.
Yeah, and it's always that one. You use it a million times. So an idea what you do.
So, do you work out the magnitude of the force?
Yep.
And I got 2 root 21.
Okay.
So 2 root 21 equals 3 times A.
Mm-hmm.
So A equals 2 root 21 divided by 3.
Yeah. And you could do it to decimal places if you wanted to, but I'm happy with that. And B.
By acceleration vector, what does it mean?
Given that a force acts on a particle mass, that find the acceleration of the particle. The angle the acceleration vector makes with the unit vector j. I think it's just referring to that one, but this one seems to be the one that was this exact one that we had here. Negative components. So this is this angle thing. Find the magnitude and hence the unit vector in the direction of A. Magnitude is that, and then that's A over the magnitude of A. So 2 over the magnitude minus 1 over magnitude. So that's just 1 over. So we want it for J. Acceleration vector between a given vector and a coordinate axis. Let's just take a look for the angles. I don't think there's anything. I think it's just they've just given it a different name. Acceleration. Did I write that down? The angle the acceleration vector makes. So that's this one here. Oh, is that this question? No. Let me just see where this is. Exercise 12D. The acceleration of the particle. Forces. The angle the acceleration vector makes with the unit. I think the acceleration vector is the overall vector, so that should just be the same thing, I think.
So the magnitude, or
let's see. So they had these 3 forces. Find the resultant force and then find the acceleration of the particle, giving your answer in vector form. So we have that. So they didn't say in a yeah, they want this acceleration in vector form. So we have to say what this would be as a vector, not as the resultant. And so this is minus 2i minus 8j plus 4k is equal to 3a. And so what is a equal to? in vector form.
Minus 2/3 of I. Minus 8/3 of J.
Yeah.
Plus 4/3 of K.
Yeah. And so this is the acceleration vector.
Okay.
Unit vector J. So we have to say what angle that makes with the unit vector J. How do we do that? Any idea how we go about that one?
Should we try and sketch it?
You could, but it's 3D.
Oh.
So I think it's going to be cos theta of J is equal to J over the magnitude of A. Cos theta Y, so there Y. Yeah, I think so. So we did need the magnitude. Okay, so what is this?
The magnitude.
Just what do we do? What is J?
Minus 8/3.
Mm-hmm. And that's over the magnitude. All right, that's divided by. What was the magnitude?
Of the bottom line.
Yeah. Magnitude of the acceleration vector. We already found the magnitude.
We did.
On this
2 root 21 over 3.
Yeah. Let's just see. So that's the acceleration. So where did their root 14 come from? So that's just of A. So I think it might be just 2 root 21 and not over 3.
Oh yeah.
And okay. What's next? We're trying to find the angle.
Do you find cos theta I?
And so how do we get theta?
The answer of that, theta is cos to the minus 1 of the answer of that.
Yeah.
I got 106.9.
151. Let's see. Maybe it was over 3, the other thing. What was it? 2 Let's try 2 over 3 root 21. Hopefully the syntax is alright. You got 150, was it? Oh, so it was 2 over 3. 2 over 3. Let's see. So, okay, so it was the 2 over 3 root 21 because that's the acceleration vector. Okay, so that's the magnitude of A. And so, yes. So the formula, so it seems like, I was thinking of the old formula. It seems like they're going with the new formula. That this is basically the formula for finding the angle, where x is either like the I, the j, or the k, whichever one you're trying to find the angle between, like with the x-axis, y-axis, or z-axis. And the magnitude of a is the magnitude of the acceleration vector, which is Pythagoras. Any questions about that?
No.
Okay, so that's, I suppose, a simplified form. I'm just used to something different, which was a more complicated thing. Maybe this would be better then. Okay, let's say this. Find the possible values of t. Okay, I think this is worth doing.
So 9 root 6 equals 2t squared plus minus 4t squared plus minus 2t squared.
Tell me if you're stuck.
Is it equal to 22t squared?
Yeah. Wait, is it 24? 16 plus 4 plus 4? So 2t squared is 2t times 2t is 4t. 4t squared.
I'm kind of confused.
Was it? So maybe something's confusing you. This is the magnitude of a, so it should all be in a square root.
Okay.
So that might be part of it. So if this was just 2i, then that would be like 2 in the I direction, 4 in the, like minus 4 in the j direction, minus 2 in the k direction. And so it would be the Pythagoras of those three. 2 squared, 4 squared, 2 squared. There's a t along with it, and so we have to put that in as well. But it doesn't change it very much. So 2 squared is 4. Minus 2 squared is also 4. Minus 4 squared is 16. And 4 plus 16 plus 4, I believe, is 24.
Yeah.
So tell me if there's anything there that's confusing.
So then would you do the square root of 9 root 6?
And what would you get?
4.7.
What is the opposite of square root?
Squaring.
Yes.
Is 54. So 54 is equal to 24t squared.
Okay.
So plus or minus 3 root 6 equals 24t.
Slow down. How did you go get that?
So
3.
54,
Yeah.
if you square root both sides, you get root 54 is equal to 24t.
No, you would get root 54 is equal to root 24 t. So there's a little thing in there, and I think it's kind of confusing you. I wasn't going to mention it because technically it's not necessary, but let's see. Basically, you're trying to solve this. You're trying to get t equals.
Mm-hmm.
At the moment, t is in a square root, so you have to square both sides. And I think you kind of felt that this t squared, eventually you're going to have to, when you're solving stuff, it's easiest to do it in reverse order of Bidmas. So instead of square rooting both sides, why don't you divide both sides first to get t squared equals? What would that be?
24 equals 54 over t squared.
You have to, so t squared has been multiplied by 24. So you have to divide both sides by 24.
So t squared equals 54 over 24.
Yeah. And now how do you get t?
T equals plus or minus square root of 9 over 4. So t equals plus or minus 3 over 2.
Was it 9 over 4? So 3 over 2. I think this might be half right. Plus or minus 4.5, which is 9 over 2. Yes, it's because we have to go up to this point. So this is the bit. I wanted to see if that would work. It almost worked. It's because the plus or minus comes sooner. If we do nothing to this, like this bit here, we could split into 2. Root 24 root t squared. I think this is the thing you were thinking of. And so the square root of t squared and square root cancel each other out, and you're left with 9 root 6 is equal to root 24t. If we were to divide both sides at that point, 9 fraction 9 root 6 over root 24. Yes, we get t is 9 over 2, and so t is plus or minus 9 over 2. So this is the easier way, but I wasn't sure if it would be necessary or not, but it was. It's because the plus or minus comes sooner. The way, so I think you were just confused because first you squared both sides, and that's fine, but then you square rooted both sides, and so that just kind of goes back to where you were again, because they're the opposite of each other. 24t squared can be split up, and so it can be root 24 root t squared, and so 24t squared, square rooted all of it, you can square root half of it and keep the other half, and that will make it a bit simpler. And then you can just solve it like normal, divide both sides by root 24, and it's plus or minus because it's the magnitude. Any questions there?
No.
I'm trying to figure out what you find tricky about this. Maybe it's just square roots. Maybe you could also just take a chance. See the very first line that we wrote down? You could put that into your calculator with x instead of t, and then you could do your first number as 999 and your second number as minus 999, and I think it would give you both 9 over 2 and minus 9 over 2. If you were really stuck, you could do that. And then, let's see, this is the second last, is it? That's the last. What is this? 10 marks. Wow. Let's just take a look at this one. Prove that the lines KR and LS bisect each other at P, and P is what point? The diagram shows this equal to that. Points KLRS such that OK. K to R. Well, that's a thinker. Let's just see what this one looks like. Okay. How would we go about this one?
So, do we start by finding the magnitudes again?
Yeah, couldn't hurt.
So, P to Q, I think, is root 46.
What was it, sorry?
Root 46.
Okay.
And then P to R, I got root 174.
Root 174. Okay, how can we find the area of this triangle?
Do we know any of the angles?
Nope. We'd have to find it if we wanted it. So any ideas what we could do?
Could we use half AB sine C?
That's what I'm thinking. But how do we get C, which is an angle?
Yeah.
85.512. So I'm thinking the angle QPR is 85.512. 85.512 degrees. And so a half AB sine C would be a half times root 46 times root 174 times sine 85.512. Try that and pray. What'd you get?
It said maths error.
You and your maths error. What did you do different from my one?
Okay, I got 44.6.
Okay, so that's roughly 44.6 centimeters? I don't know, units squared. 44.6. So I wasn't crazy. How did I find this angle? I found it by doing cos theta is equal to A dot B over the magnitude of A times the magnitude of B. Yes. And so this one, they gave us P to Q and they gave us P to R. I now recognize in the previous one, they were giving us P to Q and Q to R. So we would have to find out if they give us P to Q and Q to R, we would have to work out what P to R is, because that is, we need the same letter in the same place twice to find that angle. Okay, let's see. And then the point T, that's a bunch of malarkey. We've done enough. Let's see. Point T, P to T is that, and the point S. Okay, so find that area. Maybe there's some. Oh, it's a 2 marker. P to T. I'll leave that one. Okay, let's just take a quick look. Quick look. Come on, why won't this thing work? Come on, Penny. Okay. This stuff, Pythagoras. Yes, I think you're okay for the Pythagoras bit. Just remember plus or minus, and you're okay for that under normal circumstances. So, was this the one that gave us difficulty? Yes. This says A to B and B to C. We needed to find the angle A, because that's in the middle. And so we needed to do A dot B over magnitude of A, magnitude B for AB and AC. That's what we needed to do. So we needed to find out what AC is. So A to B is here. B to C is there. So we had to find out what A to C is. And that's pretty easy. And then you just put that into magnitude A, magnitude B, and do inverse sine. Any questions about that?
No.
So this was the one that bugged me. But finding A to C is easy peasy. That's just like adding. Let's see. So the acceleration vector. So they should have said in vector form, but I suppose we needed this thing anyway. So F equals ma, force, mass, acceleration. That part was easy, or it's even easier in acceleration in vector form. And then they wanted it with the unit vector j. So the coefficient of j was minus 8 over 3. And so it's minus 8 over 3. So basically cos theta is the j over the magnitude of the acceleration vector. And in general, cos theta is the x, so number in front over the magnitude in total. Tricky stuff. Tricky stuff. So this one gave you problems. I'm not entirely sure why. Instead of 2, it was 2t. Just put all those in. 24t squared, simplify and solve. Maybe just practice it. Maybe it's the square roots. Square roots are tricky. And then this one is a half AB sine C. And luckily they gave it to us as PQPR. And so we were able to just do dot product. This is called the dot product. And it gets us the angle between. And we had to do the magnitude. So magnitude, sine angle between times a half. How was that for you, Keelan?
Yeah, good, thank you.
And this stuff, well, God help us if that comes up. So anything in particular you want for next time, or you'll let me know?
Yeah, I can let you know.
All right, and you're doing a test on vectors, is it? Or
Next Monday, yeah.
All right. Well done, Keelan. You did great. I look forward to talking again next week. And good luck on your test.
Good week. Thank you. Bye.
Bye.